I have what may be the most random, irrelevant question that you've ever been asked. And the question is, how many folds of a piece of paper would it take to reach the sun? I actually like you to maybe think through an answer. Would it be something close to like 100 folds, 1,000 folds, 10,000, 100,000 folds? How many times do you have to fold the paper to reach the sun? And I think the answer may surprise you. The answer is actually 51. And you may be wondering, how in the world is it only 51 folds to reach the sun? So this seems very off, but this is actually the answer. And this is how the mathematics would work. So first off, the distance to the sun is 149,600,000,000 meters. And the paper's thickness is on average about 0.0001 meters. And the idea behind this is that each time you fold a piece of paper, okay, the paper's thickness would double, right? So each time it's doubling. So eventually, if you keep doubling something, eventually the number is going to get really huge really quick. All right, so what we're going to do is we have to figure out how many times would you have to multiply 0.001 by 2. So we have to keep multiplying by 2 over and over and over again. And whatever number of times you multiply by, that would be your answer. That's the number of folds it would take to reach the sun. So you could use a calculator and just keep multiplying over and over again. But we could also use logarithms to get your answer. So here's how this would work. You would have to use Algebra 2 knowledge, where we talk about logarithms, to answer this question, to calculate it. So what we're going to do is we realize that if we take the measurement of 0.0001 and you multiply it by 2 over and over again, okay, so it'll be times 2 to some power, right? When you multiply by 2 repeatedly, that is multiplying by 2 to some sort of power. All right, so that'd be times 2 to the n power. And that distance needs to equal 149,600,000,000. All right, so the question is, how do you solve this for n? So the variable is in the exponent. So this is when we use logarithms. So to solve this, what we do is we try to get n by itself. Notice the 0.0001 is being multiplied by the 2 to the n power. Let's take care of that first by doing the inverse of multiplying, which is divide. So you divide both sides by 0.0001. So you do that on both sides. All right. So now we have 2 to the n power equals 149,600,000,000 all over the 0.0001. From here, to get the variable out of the exponent, what we do is we can take the logarithm of both sides. You can take the logarithm with any base, but your calculator can only do base 10 typically, or a base e. So we're going to choose base e, which would be a natural log. So we'll just do the natural log of the left side and the natural log of the right side. Okay, when you do that, the whole purpose of doing that is to bring this exponent out in the front. All right, so we can bring that out in the front. So now we have n times natural log of 2, and now this is gone from the exponent. So now we can just solve for n by dividing both sides by the natural log of 2. So that's going to cancel on the left side. So we have n on the left. On the right side, we divide all this by the natural log of 2. So this looks like a mess, but what you do is just type this in your calculator. And when you do that, you're going to get 50.4, which would be the number of folds it would take to reach the sun. But you can't have a partial fold, so you have to round that up to the nearest fold, which would be 51. So 51 folds of a piece of paper would reach the sun. So again, it's mind-blowing, but that is how exponential functions work. When you keep doubling something over and over again, okay, eventually the numbers get really huge, right? So that's the idea behind that concept, and I hope your mind has been blown.